Welcome back. Problem 11-52. So statement is the simply supported joist is used in the construction of floor for a building in order to keep the floor low with respect to sill beam C and D. The end of the joist are notched as shown. If allowable shearing stress for wood is 350 psi and allowable bending stress is 1500 psi, determine the height h that will cause the beam to reach both allowable stress at same time. Also, what load P causes this to happen? Neglect the stress concentration at the notch. So you can see this is a simply supported beam that is made up of wood and that is acted upon by a load of P, and uh, this beam is supported on cell beam C and D. So you have to find this height h so that both allowable shearing stress occur at the same time, and you have to find the load P as well. So let's start with the solution. So first step, you can see this diagram. If you draw the free body diagram and remove this cell beam at of C and D, so there will be reaction force at point B, which is RB, and at point A, which is RA. That is shown in here free body diagram. So we will find this RA and RB by using equilibrium condition. The first equilibrium condition is sum of all moment about point B is equal to 0 and taking the counterclockwise movement as positive. So about point B, one load is P and perpendicular distance is 15 feet, and this is producing counterclockwise movement, so it will be positive. So I will write P into 15. The second movement that is produced by this force RA and perpendicular distance is 30 feet, and that is producing clockwise, so it will be negative. So minus RA into 30 is equal to 0. So 30 RA is equal to 15P. Clear? So RA will be equal to P divided by 2. So this is RA. You can also find RB by using another equilibrium condition, that sum of all forces along y direction must be equal to 0 and force upward taken as positive. So you can see here that we have RA which is upward, that is positive. So P by 2 minus this P which is downward plus RB is equal to 0. So from here you will get RB is also equal to P divided by 2. Now we'll move toward drawing shear force and bending moment diagram. So for that you have to draw vertical lines from the end of the beam, and you have to draw the first shear force. So we will draw first the shear force diagram. So X will be in feet, and here we will draw the shear force V. Okay, so let this division is equal to 0.5 P. This is P. This is minus 0.5 P, and this is minus P. So at this point you can see that at point A we have RA which is 0.5 P, because P by 2 is 0.5 P, and RB is also 0.5 P. So your first point is this. Now moving from RA till this mid, there is no other force, so shear force will remain same, and it will be just a horizontal line. Now at this point you have P which is acting downward, so 0.5 P minus P will equal to minus 0.5 P. So shear force will change to this point. So this is 0.5 P, this point, and this point is minus 0.5 times P. Now moving from this point till there is no other force, so shear force will remain same, so it will be a horizontal line, and at the end you can see you have RB which is equal to plus 0.5 P. So it will bring it to 0. So this is your shear force diagram. Now we will draw the bending moment diagram. So for that I have drawn a horizontal line to show X in feet. So first point here will be equal to, here on vertical axis we will take moment. So at first area under the shear force diagram is this one, and this area is equal to 0.5 P multiplied by 15. That will give you 7.50 P. So let this is 5P, this is 10P. Clear? So 7.5P will be in between these two, so this will be 7.50P. Also you can see that shear force is a horizontal line with a constant degree, and this area is positive, so bending moment will be 1 degree higher, and it will be a straight line and slope will be increasing. Similarly, this second area is also this area is minus 0.5 P multiplied by 15. That will give you minus 7.50 P. So plus 7.50 P minus 7.50 P will bring it to 0 at this point, and we will get the bending moment line will be like this. Because the area is negative, so we will take this line as a 1 degree and slope will be decreasing. Now you can see from this bending moment diagram from BMD, you can see that maximum bending stress is equal to 7.50 P, and the unit will be again, if this is PSI, so this unit will be equal to pounds into feet. Okay, pound into feet. So remember the length is in feet, so unit will be in pounds into feet. Okay, now we know that we have allowable or maximum bending stress is equal to allowable bending stress, and that is equal to maximum bending moment into C divided by I. One more thing, that this is not maximum bending stress, this is maximum bending moment. So now you can see that you have this 7.5 maximum bending moment is 7.50 P, and to convert it into inch we will multiply it with 12. Now what about C? So you can see the cross section here. You can see this is height is 10, this height is 10, and this thickness or width is 2 inch. Clear? And if this is the neutral axis, so this will be equal to C, and C will be equal to H divided by 2, and H is 10 inch. So C will be equal to 5 inch. Also I is equal to 1 over 12 BH cube. Clear? So 1 over 12 B is 2 inch and H is 10 inch, so 10 cube. Clear? And C is equal to 5 inch. So you can put it in this formula that allowable stress is equal to maximum moment into C divided by I. So allowable bending stress is given as 1500 psi. So I will write 1500 is equal to 7.50 P multiplied by 12 into C is 5 inch divided by I is 1 over 12. 1 over 12, B is 2 and H is 10, so H cube 10. Okay, so when you solve this, you will get P is equal to 555.56 pounds. So this is the value of P. Now what we will do is that we will go to shear stress formula, shear stress formula for that to find this height H. So for shear stress formula, we know that maximum shear stress or allowable shear stress for rectangular section is 3 by 2 V max over A. And we will take this portion. So what if I draw the cross section? So you can see this is width, which is 2 inch, and that was the height h. Okay, so we know that allowable stress that is given as 350 psi is equal to 3 by 2, and V max from the shear force diagram is 0.5 p. So I will write 0.5 into p is 555.5 divide by area, which is 2 into 2 into h. Okay, so when you solve this, you will get h will be equal to 0.595 inch, and this is the required height of this portion of the beam, clear, under which the max allowable shearing stress and normal stress occur at the same time. I hope you have enjoyed this video. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about latest video. If you have any question, you can ask me in comment section. Thank you for watching.